reasons DBAs need to love extended events. So my name is Jason Straight. I'm a database architect here at Pragmaticworks, Microsoft MVP and Microsoft Certified Master for SQL Server. Throughout the session today, if you have any questions, please feel free to drop them into the Q&A box. Otherwise, if we don't have time to get to them today, I'll respond with them with some follow-up emails and blog posts. But if you need to get a hold of me, or if you have any questions, please just feel free to ask. I'm here with Pragmaticworks. We heard a bit about them at the beginning, but they do quite a bit with BI and data platform solutions. So if you have questions about that, feel free to ask us on that as well. So getting to the task, though, for today is that we're talking about extended events. And extended events it's a dynamic, highly configurable tracing tool that was introduced with SQL Server 2008. And it gives you the ability to attach onto events within your SQL Server platform, different activities. And ever since I was first introduced to this, I've been really excited about it because it gives you that ability to go really deep into SQL Server. And I've tended to find it to be fairly amazing. The things that you can go in and do and the things I'm going to talk about today, the problems that we have with other tracing tools that we've had to live with for years are kind of gone when it comes to extended events. And I wanted to actually, initially when I wanted to put the session together, I wanted to say it was epic, but the last time I used the word epic, Tom LaRock reminded me that we know what epic means. You know, if you've ever seen Epic Food Time, they set the bar for epic. And extended events is amazing. It may not quite be epic, though. So I'm hoping that today, as we go through this, I can show you some of the problems that we have with tracing tools and some of the things that we can do with extended events that get solved with this platform. And maybe by the end, you're going to love extended events as well, or at least want to learn more about it and dig into it. And so let's get started. And so here are the 5 amazing reasons DBAs need to love extended events. Number 1 is what I call data survivability. It's that ability that SQL Server and the information that you're tracing on isn't going to just disappear on you without your knowledge. And this has happened to me so many times in the past where I know that something is going to happen over the weekend, so I set up SQL Trace on Friday night. I go home, I enjoy my weekend because it's a big issue, but it's not something that I have to babysit the system for over the weekend. A sysadmin or a junior DBA restarts the SQL Server on Friday night because they were on call, they had to go get something, and you get on Monday morning and you don't have what you need because SQL Server restarted, your trace went away, you don't have any of that information. And while it's the sysadmin or the junior DBA's fault that stuff isn't there, your manager isn't going to look at them and go, well, why did you do that? They're going to look at you and say, well, why didn't you make sure that this would stick around? And extended events has a way that retains this information. Sessions that you create with extended events don't just disappear when you restart the SQL Server instance. And in fact, you can configure them to just restart when the SQL Server restarts. And that way you don't lose anything and your data is going to survive. The second piece of data survivability is that problem we have with Profiler where you start up a trace, you get the information that you need, or at least that you think you need. A few minutes go by, you start to collect some information. You still need this information because it's kind of important to figuring out what the problem is, but you find out that, if I just had this additional event, I could make this better. Or if I had this other column. And with Profiler, you could do this. You could add a new event in, you could add new columns in, but you have to stop your trace, you have to put all your data someplace else, then you have to go and reconfigure your trace and get it started again, and then later on you have to push it all back together into a single source or query multiple tables in order to pull it all together. And for me, that was always a pain. Having to do this extra work just to be able to do the work that we think we should be able to do, it is that bar, and it always made me angry every time I had to throw data away or save it off somewhere else. Well, with extended events, you don't have that problem because you start up a session, you can add events, you can drop events. If you want no events, if you're done collecting information but you're still using the data, you can drop all the events out and it's all going to still be there. And that's that data survivability. That's that ability to collect your profiled information and not just lose it because, well, something changed. And so, yeah, you can do this, as I mentioned. You can do some of this with SQL Trace and Profiler. If you are pushing trace out to files, it's not going to be as big of a deal. But if you're using Profiler and you're collecting information, it is kind of a big deal. You could set up startup stored procedures for every time you want to run a trace over the weekend, but that's more work than we should be tasked to do. It should be as easy as clicking a button or setting an option. And that's what extended events allows us to do. And it lets us just build something once and just always have it available and at our fingertips. So let me show you how that works. Go to the first session here. Let's just drop this session I've got built. And so I built a session already that will go out there and collect some performance tuning data. But let's just start one from scratch. And so we'll create a new session, and we'll use the new session wizard. If you're not familiar with SQL Server 2012, it does come with a GUI for extended events, and so it's a lot easier to use. And we're going to call this 5 Amazing Ways. And we're going to start that session we're going to get that session started on startup. Now, let me just get zoomed in here. For some reason, I didn't have that going, but there you go. Just clicking that means that SQL Server, when you restart, your session will be there. No magic, no extra work. It's just going to be there, and it's available, and it's going to start up, and your sysadmins and your junior DBAs are not going to be able to knock off your sessions that you need in order to do your work on the Monday. And so you're going to get part of your weekend back. Now we're going to use a template that's already out there because we're going to cheat. We'll use query batch sampling. There are a number of templates that are out there. This isn't one of the amazing reasons to use extended events, but it's a pretty dang good one. It almost made that list, but we're going to do query batch tracking. All right. And if you see here, we're tracking in 3 events. Oops. Error reported, RPC completed, and SQL batch completed. So we're going to bring those in. They're already configured for us. They've got some actions that have been added in so that we have some of that extra information. And we're going to do a little filtering on it. By default, this is what the wizard already sets up. Get that going. And we want to save this off to a file, though. And we're going to throw it out here into this 5 Amazing Ways file. And so that way, if SQL Server restarts, not only will the session still be there, but we'll have it out on a file. That way we don't lose what was stored in memory. Now we've got that all done. We've got that wizard screen that I don't think anyone's ever used. And we'll just build that session up. And let's start it right away, and we'll watch it. One of the things that with 2012 you can do is you can watch sessions just like in Profiler, but within Management Studio. So we've got that going. And anytime any session information goes through here, it's going to come through. So that's that same session that we have right here. That's just scripted out. You can script out your sessions as well, but we've already got it started. If we take a look at our drop-down here, we do have it in the list, 5 Amazing Ways. So we've got that session, and if you're having that performance issue over the weekend that you wanted to insulate yourself against, you've got that available. You've got that built up, and it's already there. We've done everything that we need to do to ignore a session for an entire weekend. All right, so let's talk about accessing this data. So if we want to access the data, we can go to the XCL file and just use the store procedure to get into it, or a function to get into it. Let's just do that real quick to show you how you can get to your data and how it's going to survive for you. If you see here, we've got all sorts of data that's been collected. It's quite a bit, and it's been sitting out there for a while, and that's data survivability. You know, if every single time that you did analysis on CX weight stats, CX parallelism, use the same file, and you kept the files out there, you would be able to go and do profiling over time and take a look at that kind of information. The data that you build out survives. Now, it's also up in memory, and so we can go and check memory as well and take a look at what's been collected. I think right now that we've only had, you know, the one statement that's been run. If we wanted to, we could throw a few other statements out there. So let's run a script real quick, get that running, and we'll watch this live so you can see it coming in. And it may take up to 30 seconds. That's about the default that Extended Events takes. But let's just take a look real quick and drop out a session. Drop out an event from a session. You can drop an event from a session or add events without losing your data. So let's drop that error one out. We didn't need the error one. We don't want it. And we can go out there and we can check to see which events are still associated with this. And we can see that we still have RPC and SQL batch completed. They're still out there. They're still being collected. If we go and we look at that live data, we can see that the items are out there. We can bring some of those other columns up if we wanted to see what was being collected. But that data survives. It's all there. It's all available for us. And that's that first reason why I think Extended Events is just a great thing for DBAs to be using. So just to recap, Extended Events, as we go through this, you're going to see that they're highly configurable. You can take active sessions. You can drop and remove columns, drop and remove events, set it up however you want, get it going, get it perfect. You can leave and not have to babysit it, and it'll still be there even if somebody restarts the server. So that's that first reason. Now, our second reason, you get what you want in your session. You don't have to do a lot of voodoo to figure out, well, what does this column mean? Where is this data going to come from? Oh, I want to bring in plan handle, and I actually want it to be populated with something that's useful. Well, Extended Events gives you that. You can pull in whatever you need. So if you've got some performance issues that show up, and this is similar to the first one where you need to add in new columns and get the right columns in there, you can get to all that. You can change traces and bring in the things that you need without losing stuff and without having to have columns in there that you have to figure out. And so that's that text data column. If you want to figure out what's in there and you want to do stuff with the data that's in there, well, there's other options with Extended Events like the T-SQL stack that you can use to figure out what kind of statements are in there. You can bring in query hashes. You can bring in plan handles. You don't have to have some sort of voodoo translation device to figure out what big int data 1 means or big int data 2 means. With Extended Events, they didn't add in those kind of junk fields that collect everything. Every kind of field that's out there has a name and has a definition, and that kind of data is in there. And you can start aggregating your data then based on these things. So if you bring in plan handles, you can do some aggregations on your plan handles and see how often they're being executed and that kind of stuff. So you've got the plan handles, you've got query handles, query hash, T-SQL stack. You can separate out everything that is from the SQL Server system and have it not in your results. You've got a histogram that you can do group bys on with your data so that when you pull your data out, you're actually pulling out an actionable list of information. You've got your event counter, your event counter. Nice little typo there. Your event stream. So if you want to build an app that streams out your data, well, you can do that. You can get exactly the data that you want where you want it. You want to play with this data in PowerShell, you can do that. You want to stream it into a .NET app, you can do that. You're really empowered to do the things and process it and deal with it the way you want to natively. You don't have to do a lot of extra work to it. So let me show you that. So we want to get what we want. And so what we're going to do here, let's start by just showing you the different actions that are out there. And actions are these, what are in the GUI called global fields. Global fields are those extra fields that you want to bring in. So if you want to add some extra stuff into any sort of an event that doesn't have it, you can add that in. And so if we take a look at some of the actions that are out here, they're going to be things I already mentioned. Plan handles, query hashes, query hash plans, SQL text. If you've got issues that you're trying to track down with your hardware, and you're trying to figure out, how is this working with this CPU? I've got a hot CPU. What's running on that CPU? What's running within the NUMA node? You can dig into that. You can get that information so you can tie it all together with other information. You've got the multiple targets that I already talked about. The main one here, one of my favorites, is going to be the histogram or the bucketizer. The histogram is called a bucketizer in 2008, and it's a histogram in 2012. For all intents and purposes, it's the exact same target. They only changed the name. Now let's do a little bit more here, and I want to bring in my plan handles into this session that I was working on. But before I can do that, I need to actually use an event that actually uses plan handles. So I need to drop out this RPC completed and SQL batch completed. So let's pull those out. And if you remember, I said data survivability. The data is going to still be there. We've got right now no events tied into this session. We've pulled them all out. Well, let's add in 2 events that use plan handle, because that's what we want to bring in. We want to bring in plan handle and also bring in T-SQL stack. I'm kind of a fan of that as well, but we're not going to use that in this demo. So I'll bring that piece in. All right, so now if we take a look at it, let's run some activity in there real quick so that we can get that populated. Run through that 30 seconds it takes to collect. And we can see we've got those 2 additional events. So now that we have that information, what is it that we want to do with it? Well, let's pull it out and let's grab the plan handles and take a look at those, because that's what I want to dig into. I want to pull in the plan handles because maybe I want to do something with that later on. So let's run through that. We can get the results here. Let me just move this over to the side. And we can see that, oh, actually we don't have plan handles. Well, that's kind of sucky. Well, actually we do. The old data that we collected didn't have plan handle, but that's okay because plan handle wasn't collected for it, but it's still there. Well, we have plan handles with all the rest of them. The next 25 that we ran, we've got plan handles for. And so as you add in that data, you can get the data that you want, so you can build the sessions that you need to solve your problem. So when you discover, hey, I need plan handle, you can add that in. You've got that information available. And you can use that to then, well, before I give away number 3, let's just summarize. Extended events, highly configurable. You can get what you need. You can add in the actions to get columns that you need, create actionable traces, traces that you can actually work from exactly when you get the information back. And of course, you've got those extra targets, so you can start to, of course, build better actionable traces. Now, I was about to say something, but that leads into number 3. The reason why we want to have things like plan handle is DMV integration. You can take, since all this information is stored in SQL Server, it's all available through functions that you can go out to your trace files or DMVs that you can go into your ring buffer to pull back the data that you were tracing. You can write some XQuery against it. And you've probably seen or noticed that I've been using a lot of XQuery for pulling all this out. But you can use XQuery against it to pull out the plan handle, to pull out the query hash, to maybe go out and get your execution plan and start building queries that go against your traces that give you actionable information. So because DMVs, they give you some summary information, aggregate things out like query stats, or maybe you need to dig deeper to get to the plan, to take a look at an execution plan. You found your problem queries, well now let's see what that query is doing. And that is what you get through plan handles and query hashes. There's the T-SQL stack, which is just like that .NET stack that we would see in the developer world, where you get the stack trace of all the T-SQL statements that were called. So the top level stored procedure that was called, you get the SQL handle for that within the T-SQL stack. Below that, maybe there is a function that was called. And so you get that function. And maybe that function calls another function. So there you go. And maybe then that function queries against a view. So you get the SQL handle for that. And you can go all the way down, and maybe that view's got functions that are built within it. You can start to unwind what is being developed against your system to see exactly, well, you've got this one statement that's bad. How did you get to that statement that helped make it bad? Maybe there's a loop that's tied into it that you just didn't know about. You're tuning this one little SQL statement, and there's something above it that's actually causing it to be the burden that it is on your system. And that's important because you can build actionable queries that tie into your traces where you can start to fix the problems right as they come up. And let me take and show you guys that. All right, so let's go back to our 5 amazing ways piece here. And so we've got our 5 amazing ways. And we can pull that out, and we can take a look at the XML that comes back, and we know that there is, let's see here, let's come down here a little ways. The GoToMeeting piece is actually covering up my slide bar. Right, so we've got this plan handle. And from this plan handle, we can convert it out, maybe make it into a varchar, and then query against it with exec query plan. So say we wanted to go and get the execution plan. So let's just run that. And what you're going to find out right away is that this doesn't work. Well, there's a reason why this doesn't work, and that's because we're bringing back a hash value as a string. So let's go to a query version that does work. And so what we want to do is, and this is one of those things that, even though you can tie these into DMVs, there's a little extra work that you need to do in order to pull this out. And so we want to take that plan handle and turn it into a binary value. And so we'll do that. And we'll show you what this looks like. Oops. Let's do it once without the exec query plan. Run that through. We can take a look at the results. And, well, that's interesting results. What did I possibly do wrong here? That is not how it's supposed to go. All right, for some reason this got broke. I must have tweaked it at some point and broke it. So let's just do this instead, because I can fix this pretty quick by just doing a convert on this. So let me just do that real quick. Of course, don't type in a demo. Don't save your demos when you're not paying attention to what the outputs are supposed to be. Let's see if this comes back with the right value real quick. This should. If this doesn't, I may just all right, not sure why that's not suddenly working. Well, let's go back up to here. We can at least monkey this around And let's just pretend that conversion was working, but not go into there. Let's just run through that. Let's take one of those values. Put the 0, the X on it, and add that in. So let's pretend for a moment here that my query wasn't acting just goofy there for a moment, and we actually were able to do this join that we've got here. Well, then, if we had that, we'd be able to pull back the query plan. Now, I may be doubting whether or not this really works, but I do have a demo that I'm going to do, a couple more demos that I'll do that actually does this. So we'll pull this back in a different demo that will hopefully work, but for some reason it didn't tie up here. But you do have plan handles there, and you can tie that into your exec query stats, your query plan DMVs, and get the additional information out. So if you wanted to find out, how was that query running, that information is out there and available, and so you can start to do additional work off of your traces as you learn more about what's going on. All right, so a little bit of a speed bump there because the query didn't do what it was supposed to do, but hopefully you got the idea that the DMVs allow you to dig deeper into your results and get more detail. Build a complete picture so you can just run one query and get the entire result set back, knowing what you need to do next. And I talk a lot about actionable results. That's because we can build up these queries and we can build up processes that we don't have to tinker with too much, and we can actually start to do things and spend less time rebuilding the architecture and more time implementing solutions. And the last bullet here, and I didn't talk too much about this, is that when it came to using things like Profiler, you had to do a lot of work before you could use your results. Well, that's not the case here. We can start to use the results right away. Now, number 4, the number 4 reason, and this is the reason that I get up in the morning. Well, not really, but it's one of the great things about extended events is the fact that you can tie extended events very easily into the weights and queues methodology. Weights and queues is a great methodology for finding out, so sure, you wrote your rockin' queries, you've got your killer applications, and everything works great, except it doesn't. And weights and queues can help you find out, well, why isn't my app performing well? Am I running out of memory? Am I using too much CPU? And sure, you could go to perf stats and take a look at those and go, oh, perf stats are high. But weights and queues gives you a better idea of the root cause and the next steps to take in order to solve that problem. Well, when you're seeing high page latches or high parallelism or high SOS scheduler yield, where do you go next? What are the queries that are causing this to happen? Do you just go to a DMV and hope that the things on top are the ones that are causing the problems? Do you just look at the queries that are using high I/O because you've got an I/O weight? That was what we used to do. But with extended events, we can go directly to the queries. We can find out which queries themselves, which databases are leading to these issues and leading to these higher weights, and find out how we can go through and either say, well, we just have to live with this weight being higher, or, well, we can do X, Y, and Z to this query and make things better. And so we can take what comes out to us from OS wait stats and waiting tasks and dig in deeper. So, and that brings me into a scenario that I ran into a while ago when I was showing somebody wait stats. I'd actually been asked to come out to a client, and they'd been having some problems with their application. They'd recently done a code release. Of course, everyone insisted that the most recent code release had nothing to do with the performance problems, because code releases never change performance. And what they had happen is in their typical day, they would see about a 40% CPU hit. So CPU was pretty static at 40%. Then they do their code release, and then every day from like 9 a.m. until about 4 p.m., they sat at 100% CPU. And the system was trashed, users couldn't get in, all the things that tell you that there's a serious problem going on. When we looked at wait stats, we saw that SOS schedule yield was very high. It was phenomenally high. And there was lots of waits, and there's a lot of counts, and it was almost like a one-to-one count between waits and counts. And so they're basically having all this CPU thrashing as the SQL Server was trying to get through this workload. And it was basically like death by a million cuts. It couldn't get any work done because it was trying to alleviate CPU pressure by letting something else go and giving up and moving around and reshifting its workload to try to get something to get completed, which was just basically making everything worse. And looking at the high CPU items in the DMVs just didn't give us what we were looking for, because we knew that the overnight jobs were not what was causing the problem after the code release throughout the middle of the day. And so we took extended events and we set up a session that was tracking SOS schedule yield. We let it run for 15 minutes. I think it was 15 minutes. It may have only been 5 minutes. But we just let it go for a little bit of time. We didn't want to leave it running for too long just in case some of that observer overhead was a problem. I mean, which it was, because extended events is actually fairly performant. But within just a few minutes, we tracked down that 99% of the SOS schedule yield waits were tied into 6 queries. And just looking at the code for those 6 queries, we knew that 5 of them were from the most recent release. And we looked at those queries and we looked at what was going on, and the first thing I asked the developers was, so are you guys using Hibernate? And the answer was, of course, yes. What they were doing is they used Hibernate, and they told Hibernate to use all the defaults and guess what all the data types were. And basically their problem was that they were doing scans against some of the biggest tables in the database because Hibernate got all the data types wrong. And when we got to the point of fixing it, all they did was they did one code change to a DLL that managed the data types, and it completely fixed the issue. They went back down to 40% CPU, and performance was rocking again. Without extended events, we still would have solved this problem, but it would have taken longer. Without extended events, we can't make that direct line connection between a wait and a query. Now we can look at OS waiting tasks, one of the DMVs that's out there. Oops. We can look at OS waiting tasks, and that's going to tell us what's currently waiting for some sort of wait stat and the query associated with it. But what if the query that's the problem doesn't run every time you run DMOS waiting tasks? Because waiting tasks is a point in time, and you need to find out what are the queries across, say, this 15 minutes or this 4-hour period that are causing the problems. Well, you can't do that with waiting tasks, but you can do that with extended events. And you can make that direct connection between a wait and a query. And so let's go through one of those examples. So scroll this over so we can see a little bit. So we're going to create a session. I'm going to create the rest of these sessions using the create statements. We could build all of these with the GUI, but I want to add in a special target that the GUI doesn't currently support, or I've never seen the GUI able to support. What we want to do is we're going to collect wait info. Wait info is every time a wait occurs, it's either wait info or wait info external. From there, we're going to grab the T-SQL stack, and we're going to grab the plan handle so we know what the SQL statement information is. we're going to grab weight type 124. In this case, I'm going to run some queries that cause SOS schedule yield. We're going to ignore everything that SQL Server is doing internal. So anything that SQL Server is doing to run the service, to manage this, that, or whatever, we're ignoring those because we can't tune those. We want to look at the applications that are running against the system and the queries that are running with it to find out where those problems are. We're going to throw everything into the ring buffer. I just do that as a default. What we really care about, though, is this bucketizer. And what this bucketizer is going to do is it's grabbing the event, wait info, and it's going to group on the T-SQL stack. So every distinct T-SQL stack that comes through, it's going to collect information on that and count up the occurrences that happen. And then we'll just start this session. So let me just get this going. And we'll blow out the plan cache here. All right, so we've got that built. And if you want to know where I got this 124, it comes from one of the DMVs that come with extended events. And so I'll actually just, let's comment this out so you guys can see that you can get to any of the DMVs that are, any of the weight stats that are out there. So they're all there. If you've ever wanted to do that deep connectivity between weights and queries and figure out exactly what's causing it to happen, this is the way to do it. This is that amazing reason, that amazing feature. All right, so I created a table here earlier where I've got person contact, I've got some first names and last names, I've changed them to varchar because we're going to cause an implicit conversion issue to occur. And so I'm going to look for this guy within there. If I run this just once, you'll see, if I go to the right database and run this just once, the right database is always a big deal. We get 5 people to come back. We look at the execution plan, and we're getting that implicit conversion. And actually, if you're using SQL Server 2012, it's going to tell you that you got implicit conversion issues. So maybe you don't get to the point where it becomes that problem. Hopefully your developers are looking at the execution plans. They would actually see that and cause this to never ever happen again because developers are paying attention to that kind of stuff. And all the DBAs right now are laughing because they know that that's not true. So let's bring up the SQL load generator. And let's add a query to it. And we're going to add this query in. Let's just run 25 concurrent versions of this. And so what this is going to do is it's going to run this one query where it's causing the implicit conversion, and it's just going to get going here. And so if you're here near my laptop right now, you'd actually be hearing the fan picking up pace. And let's take a look at weight stats. So I'm going to just create a temp table that's got some weights in it. And if we take a look at the weights over time, we're going to see the SOS schedule yield is starting to, one moment here. All right, I just got a notice from GoToMeeting that I'm overloading my machine here, so I'm going to stop this workload. Not had that before, so obviously I put a little bit of a workload on here, and if we take a look at SOS schedule yield, we do see that we did have quite a few there. We had some time that's associated with it, and now let's find out. This is what we would typically see when we're doing weight set analysis. We see some weights that are kind of high. Let's go figure it out. Well, we've got the weight stat session, the extended event session created. Let's dig into it. So we can dig into it this way, and we can take a look at it, and we can see here's some XML that's got all the weights that have occurred. Okay, not a big deal. The histogram, that was that one that said it's going to do a group by. So let's bring that out. And so let's take a look at, we've got this first line item in here where there's 62,400 occurrences of this T-SQL stack. Well, when we're looking at the fact that we had 194,000 of them, whatever is associated with this 62,000 one is probably a big deal. Well, let's dig into that one a little bit. And to do that, we'll pull everything out here, and we'll pull out the histogram, and we'll bring out that T-SQL stack, and all of this code will be available after the fact, and we'll bring in and do that binary parsing that didn't for some reason work on the last demo. The T-SQL stack has the offset and the start and the end offset, and so you can go into SQL, the DMV for SQL text, pass in the plan handle, use the start and the end, and you can find that SQL statement. And then you can pull everything together. And if you see here, we're tying in SQL text, we're tying in exec query plan, we're bringing in some query stats. I talked about DMV integration. You can do that, you can build out a solution. And so let's take a look at that. We look at the results here, and so we see that there is one line that has the 62,000. I would say that, you know, these other queries, let's not be too concerned about those. Then we've got the frame levels, we've got the database. It's interesting that we don't have the DB name here, but it's because it's ad hoc SQL. We've got the SQL handle, schema and object name if it existed, but we're not using a store procedure. But here is that query. The query that was causing the problem is right there at the top. And so if we grab that query and we start digging into it, we can see if we can get this to come up here. There we go. We can see that the implicit conversion warning message is there. We can see that we've got the index scan. If we hover over and we bring up the notes, we've got that convert implicit. And so we get to that issue, well, the query that is causing all of those waits to occur, and we can dig into them. And it's not much work, it's just there. There used to be a strawberry daiquiri commercial that I heard quite a bit in the mid-90s, and their slogan was, "It's already ready already." Well, extended events, it's already ready already. You can tie everything together. And so just to reiterate, and I've been going over these over and over again, you can track specific weights. You've got that weight that's accumulating there. Paul Randall pulled together a way that you can actually look at weights for a specific database. So if you don't want to look at weights for a server that's got 1,000 databases on it, well, there's out on SQL Skills, there's a trace that Paul Randall put together that will look at just a single database and pull back your weights for just that one database. That's kind of a powerful way. You know, if only one client is paying for you to look at their database and look at their weights, well, just look at that one. And so with weight stats and with extended events, you've got like that perfect pairing of Batman and Robin, the way to get in there and dig around. All right, that was number 4. And number 5 is latch tracing. If you watch around on Twitter quite a bit, there's a lot of people that end up having questions about latching and how to go into it. Looking at latching within TempDB, digging around and figuring out what's causing this specific performance problem that I can't seem to try anything into. Well, similar to weight stats, you can dig deeper into latches. As latches are occurring, you can dig into them. And if you're not quite familiar with latch tracing, here's my 5-second slide on it. It's lightweight synchronization activity that happens within SQL Server to make sure that things like memory allocations are still available while SQL Server is trying to pull stuff up from disk. Making sure that when you do page allocations that somebody else doesn't come and take it and use it for something else. Making sure that if you're transferring stuff within memory, that the two places are still available until the operation is completed. If you want to dig deeper into which latches are occurring in your system, take a look at DMOS latch stats. The main way in which we're going to typically see latching occurring or latch issues on our system is we'll see wait stats that relate to latching. So latch X or page IO latch or page latch. All these talk about the different types of latching that's out there. But with a lot of latching, there wasn't much we could do unless it was page IO latch. If it was page IO latch, we knew, hey, this is a disk issue. When it comes to just latching or just page latching, there's not a lot of we can do without understanding what's going on deeper below the system. And that's where extended events gives you that issue. And so consider a scenario where you've got a new application that's deployed. It's got a lot of users, and you're seeing lots of latch X waits. And it's all on that one database. Well, how would you solve that? How would you dig in and figure out where that problem is? Some other applications appear to be affected, but as soon as you just got more users, this application slowed down, and you need to find out what that problem is. Well, extended events is going to give you that ability to dig in and look deeper. And so let me show you. And this is one of those demos that I saw this demo at PASS a good 5 years ago, and it just completely sold me. It was just sold me completely on using extended events. So I'm going to create this store procedure, and the store procedure is doing a couple things. Selecting some data out into a temp table, it's updating it, and then it's returning those values. Nothing too exciting. If you saw a dev doing this, you may not actually even freak out because it looks completely harmless. Let's get that created. Let's take a look at the waits that are occurring on the system, and if we take a look at what's going on right now, we're going to see that there really isn't anything that's going on. We've got some dirty page pool, some sleep tasks, so SQL Server is just trucking along doing nothing. We can create a session on latch contention. And so we're going to look for the latch suspend end event and just pull back any exclusive or update latches. We'll put this information into a bucketizer and then do the T-SQL stack. As I mentioned earlier, this is one of my favorite ways to get to where the bulk of the activity is happening the fastest. And it does all your group bys for you right away. And I've actually put onto this a match dispatch latency of 5 seconds because I don't want to wait that 30 seconds that we were waiting earlier because this is the demo. In production, you would generally not put in modifications in your dispatch latency because you're not going to need to be that quick at getting to the information. Let's get this started. Now that we've got that started, let's run that stored procedure. So go back to my load generator. We're going to do the what if. Run 15 concurrent versions of it. We'll get this kicked off, and what I want you to pay attention to is this number of runs that's right here and how long it takes for us to get to 2,000. Now, it's not seeming like it takes a lot of time. But this is one of those issues where as your SQL Server gets busier, you may start to see things slowing down. And so that was probably a good 15 seconds to get to 2,000 runs. That doesn't seem like a bad thing, unless, of course, we take a look at the wait stats. And the wait stats are going to show us that we have page latch X going through the roof, nearly 1 million occurrences. And for a system to have that kind of a change in profile, just by deploying out one store procedure, you're going to want to go in and figure out what's going on. Or at least I would want to go in and figure out what's going on. Well, we can take a look at what's out there. And we can take a look at that histogram. Like I said, we're using a histogram that way. And we can see that 900,000 of them coming from one place. And if you remember, I said T-SQL stacks give you that multiple layers. Well, in this case, the T-SQL stack has the 2 layers. This is the stored procedure that was being called, and this is the SQL statement that was being called. So we can trace this back to exactly what was going on. And so we want to take this one and start at 224 to 404. And we'll just drop that in there. And of course, in this point, you might be thinking, hey, why didn't you do the DMV integration? Well, let's just do this real quick so we can see, going to SQL text, what it is that's coming back. And we can see that all of that wait issue, all of those latches that were occurring, and digging into it is that update statement. And try to think about what you would do to figure out that that update statement is the problem without extended events. How long would it take you? How many times would you have to run different queries in a loop in order to figure out, yes, absolutely, this is the problem, when in just a few seconds we were able to identify it. Now, of course, we would want to dig a little bit deeper and throw something together that would go through and tie into the different DMVs. And you can easily do that here as well. So let's run this, and we get to the end, and we can see that we've got the two levels of the T-SQL stack. We've got the 900,000. And so we know that it's this store procedure and this statement. Now, of course, at this point, we go and fix it. And so let's just fix this query real quick, because as the DBAs and awesome developers, we know that you don't need to select it out and throw it into a temporary table so you can update the temporary table so you can return the values. You could, if you wanted to, just return the values. And so let's just modify that store procedure, and we'll rerun this and pay attention again. How long does it take to get to 2,000 executions? And the answer is going to be, it's not going to take long at all. It's going to be seconds. And so we've just by using extended events and digging into those latches that were occurring, we pulled out all of this mud that was gunking up the system. And if you're spending resources on one thing that's being slow, there's something else that can't be fast, because the resources that it needs are going to be being used somewhere else. And so that's that latch tracing. And so latches are hard to troubleshoot. And with extended events, you can dig down in and you can figure out what's going on. And so those were my 5 amazing reasons DBAs need to love extended events. You can have the data survivability. You get what you want. You can integrate your results with DMVs without a lot of extra effort. You can get into wait stat tracing. You can do latch tracing, and you can start solving your problems right away. Now, I told my boss that I would actually have unicorns, bacon, and lightsabers in my slide deck, and so this is my lightsaber slide. That's the only reason why it's here. So if you want to learn more about extended events, you can go out to the Learning Center for Pragmatic Works. There's a number of sessions similar to extended events that I've done in the past for Pragmatic Works. We also, though, have a performance tuning class coming up this fall in Boston. It's a 5-day course, 8 hours a day. It's going to be me, it's going to be Jorge, it's going to be Bradley. We're going to be doing a deep dive training on performance tuning. And so if you want something that's deep dive and you want to spend 5 days doing it and you want to go to Boston, here is your opportunity. So take a look at that. Now, if you want more information, though, on extended events, you can go to my resource page on my blog at jasonstraight.com/go/xevents. Send me an email. As soon as I get the time, I will reply to it. And at this point, I think we are ready for any queries, any questions that are in the queue. And I think we've got just a couple minutes.
Wonderful. Thank you, Jason. There are a couple questions. The first one is, any way to parse from XEL file instead of the ring buffer?
Yes. The second query that I had in there let me just jump back just so I can show you guys that you could actually do that. I didn't spend a lot of time focusing on it, but here you go. Here is the XEL file that I was using, 5 Amazing Ways. And here is the results. So let's just pull this and run it real quick so everyone can see. We're accessing the file. The comment even says so. And what should work? There we go. The file might be actually getting a little bit larger because I've been playing around with these demos for a few days. So yep, you can. It's just a matter of using this function.
Okay, and is it possible for you to make the scripts available on your blog?
Absolutely. I will put them out there this evening with the slide deck and the code.
That would be wonderful. Thank you. The next question is, do these examples only work with SQL 2012, or can they also be used on SQL 2008?
They can be used on both. The only difference between the 2012 and the 2008 is, well, the one thing is you can't use the GUI on 2008. That's why I kind of focus still on the DDL and the xQuery to get the results, because that makes it portable between the two environments. And then the other big change is, I mean, there are some events that don't work between the two, but the other big change is the target for bucketizer versus histogram.
Okay, and the next question says, in the histogram, it looked like you had more than just one field and the count. Was that the case?
Yeah, let me bring up that histogram. So in the histogram, what we end up having is, oh, that was the ring buffer. Let's try doing the actual histogram. All right, so we bring up the histogram, and in here, what you end up having is, so here is the T-SQL stack that's there. So that's your value, and here are your slots, and then this right here is the next one. So we can just push that down. So here's just one item within the histogram. These frames are the T-SQL stack to dig in. So it's just the slot count, the slot with the count, and the value that you associated with it. It's just in this case, I use something that has multiple values tied into it, because this is the exact stack to get down from calling the store procedure to calling the SQL statement.
Okay, and we have time for just one last question, and it is, can we run GUI in 2012 for SQL 2008 R2?
That answer is no. You can't run it, but you can create your sessions on 2012, script them out, and then as long as you're not using events or actions or targets that aren't supported in 2008, you can then run those scripts on 2008.
Okay. Thank you so much, Jason. I'm glad that we had you here today, and I think that you have some upcoming sessions here maybe next month?
I think so.
Okay, perfect. And just as a reminder, everyone, our sessions are recorded, and they will be made available by the end of the day tomorrow. If you go to pragmaticworks.com, go to our Learning Center, and you'll find them all in the past webinars. So thank you again, and enjoy the rest of your day.
Thanks, everyone.
All right, bye-bye.